Dr. Sridhar. We are active with another video session on various tie-set and cut-set matrices. We are going to discuss about tie-set and cut-set matrices in today's video session, and in what way these matrices are useful to find out the currents and voltages in the electrical circuit. So if we know that methodology to identify the various parameters associated with the electrical circuit, now that is added benefit for us, and with the help of network topology we can simplify the complex electrical circuits also. That is a major advantage of this network topology. So if we could start the basic tie-set matrix from the knowledge of the basic loops. So basic loops are nothing but those are the tie-sets we can obtain the loop matrix. So tie-set matrix is nothing but for a given tree of a graph. So tree is nothing but more exactly we have to ensure some of the parameters at the equivalent tree of a given graph, and the branches of the tree can also be called as the twigs, and the tree could be formed by considering all the nodes of the original graph. And next one is there should not be any closed paths, and one more thing is nothing but the total number of elements in the tree, or the tree we have to develop by considering n-1 number of branches. So what is that n? N is nothing but the number of nodes that original graph is having. So like this, the tree could be developed from the given graph, and addition of each link between any two nodes form a loop called the fundamental loop. So if a link is added, suppose if the tree, if you could consider a tree like this, suppose this is a tree and this is extended between, just the same example I am considering here, node 1, and this is node 2, and this is node number 4. This is my node number 4. So this is element number A, B, C, D, and this is element number E, for example, if these are properly marked here. So what do you mean by the fundamental loop? Here we are talking about the fundamental loops. Sometimes this can also called as a basic loops. So what is this basic loop means? Now from the tree, now the tree means we are going to develop the tree from the original graph. So graph has been equivalently represented with a tree. Then some portion of the tree if you could examine. So if you want to identify how many number of basic loops we are going to get. Suppose same case, same example if you could take, and one more section, it might be, this is node number 3. So node 1, node 2, node 3 and node 4. This is the tree of a given graph. So in that cases, how many number of links are there? So links are nothing but here number of branches. More exactly if you are talking about the twigs are nothing but n-1. This is nothing but 3. Because n is nothing but number of nodes are 4. So 4 minus 1 is nothing but the 3. So what are these twigs? Twigs are nothing but these are the sides of the tree, which are nothing but branches of the tree. So next one is links. So links are nothing but how many number of links? So these are the links are how we are going to identify the links means these are the sides of the core tree, which are nothing but we are going to represent them with a discontinued lines. So the number of links are nothing but total number of elements minus number of branches. So this is nothing but the total number of elements are nothing but 6, and number of branches is nothing but twigs here. So these twigs are nothing but the 3. So we are going to get this number of links are 3. So the 3 links are nothing but can be represented with a discontinuous lines. So this could be a link. So how many links are there? There are 3 links are there. So here the question is, what is this basic loop? Now with the addition of a link, if you could develop a loop, that loop would be a basic loop. The condition is in that basic loop, or if you want to say that loop as a basic loop, and in all the sides of that particular loop, only one should be the link. Then that basic loop is because of the associated link. Now suppose now we can develop a basic loop like this. Suppose now let me take one more simple example here. Now this is node number 3, and this is node number 4, and this is node number 1, and this is node number 2. So this is one link, this is also one link, and this is also one link here. Right. Now See, this is a basic loop. This is a basic loop, and this is also a basic loop, and throughout this outer cell is also a basic loop. Here, this outer cell, if you could see, in this one, this loop was formed because of three elements. What are that elements? This is the element number D, and this is element number A, and this is element number F. In this element numbers D, A, F. So this is nothing but it is going to get one loop. But here the sides of the loops are three elements. That loop have been formed because of three sides, three elements. What are they? That is element number D and element number A and element number F. Out of these three elements, only one element must be the link. Then this loop becomes basic loop. That is the condition. And how many number of twigs or how many number of branches? Immaterial here. Only if any loop, if it is formed because of various elements, and in that elements, if only one element is linked, then that loop would be a basic loop, or sometimes this is also called as a fundamental loop. See, this loop, first one, this outermost loop have been formed because of element number D, element number A and element number F. So what is this element number D? This is a branch or twig, and this element number A is nothing but it is not a twig. Of course, it is a branch, but it is a link. And element number F is nothing but it is a branch, and it is also a twig. So D and F are belongs to the twigs, and element number A is nothing but it is a link. So this loop is nothing but definitely it will be a basic loop. Now this basic loop is because of what? Because of element number A. So what is the direction of this basic loop? Means the direction of this basic loop is in the same direction with the associated link. What is that associated link? Associated link is nothing but the element number A. Suppose if the element number A is oriented towards node number 1, then the loop direction is nothing but this is the direction. So like this, we are going to develop, or we are going to identify the basic loops or fundamental loops, and what is the orientation of that basic loop and fundamental loop is nothing but the orientation is in the same orientation or in the same direction of the associated link, because of which we are going to say that loop as a basic loop in the same direction of that link. Now we have to clearly mark the orientation of that basic loop. So similarly, let me examine the same concepts for another mesh, another loop. So suppose now this is the node number 1, and this is node number 2, and this is node number 4. So what is the relation here? Node 1 is connected to node 4, and this is connected to node 2, and between them there is one link is there. That link is nothing but, what is this link here? That link is nothing but A might be B. So if you are taking the element number B, if it is like this. So this is also a loop. That loop have been developed between node 1, node 2 and node 4 with the help of element number B, element number D and element number E. So this is E and this is D and this is B. So B, D, E, these three sides or these three branches develops one loop. Now after that, whether it is that loop is a basic loop or not, how we are going to ensure that means, now you have to examine all the sides of that loop, and if only one branch falls to be a link, then that would be a basic loop or fundamental loop. Now sides, if you could examine here, B, D and E, and B and E, B is nothing but this is the link, and D and E are nothing but the twigs. Then definitely this would be a basic loop. And what about the orientation of this basic loop? Now the orientation of the basic loop is in the same direction of that B. If the direction of this B is from 1 to 2, then the loop is nothing but that basic loop direction is also in the same direction. This is what the basic loops concepts are. So in a loop, there exists a closed path and a circulating current. Of course, now whenever it is a closed, now definitely we are going to see some current. Of course, we are going to apply this concepts of current and voltage, that is nothing but associated electrical parameters, active sources and passive elements. All these things we are going to apply at the end. But at the beginning itself, we should know the various fundamental concepts like what is that basic loop, what is the difference between loop and the basic loop? Now the difference is very clear that basic loop is nothing but it should be formed with any n number of tweaks, but one element must and should be a link. Then what about the direction of that basic loop or fundamental loop means? In the direction of link only, we are going to assign the direction of that basic loop. So the fundamental loop formed by one link has a unique path in the tree joining the two nodes of the link. This loop is also called as a fundamental loop or F loop or a tie set. This fundamental loop or basic loop is also called as a tie set. The loop orientation is to be the same as the corresponding link direction. This is very, very essential with the help of, because we had to develop the matrix. So that matrix is nothing but the tie set matrix. And again, elements would be either +1 or -1 and 0. So +1 and -1 based on the direction only we are going to mark. So that is the reason for everything, for either it may be a branch or a twig or link or a basic loop or whatever it may be, you have to clearly earmark in which direction that element is existing. So the direction is very important. With the help of the direction only, we are going to identify the elements in the tie set incidence matrix. So that's what next thing is nothing but how many number of basic loops we can develop in a given graph. So basic loop is nothing but that condition is that loop must and should be developed with any number of elements, but among them one element must be a link. So it is clear that how many number of links that graph is having, so that many number of basic loops we are going to see. So that what could be the number of basic loops or fundamental loops means, now straight away we can say that number of basic loops or fundamental loops is equal to number of loops the graph is having. So number of loops will be equal to the tie sets. So that is the one thing. And what is this? This is going to discuss about the relation between the number of branches and the links. That is nothing but the loops. So that is the reason the size of this tie set is nothing but L by P matrix. This is called as a fundamental loop matrix or tie set matrix. The tie set matrix is written as B of the elements are always Bij. So what is this Bij? Bij is nothing but B, all the elements are nothing but the Bij. So we are going to develop or write the matrix with the elements as, the size of this matrix is nothing but the L by B. So how many number of branches are there and how many number of links? That number of links are nothing but the loops. So basic loops, how many are there? Suppose now number of links are 3 links. So 3 basic loops. So loop number 1 and loop number 2 and next one is the loop number 3. And on top of this matrix, we are going to write about the branches. So when it will be positive, the element, suppose if when this will be positive and when this will be minus, negative, when this will be 0 means, now here the element is nothing but we are going to develop the relation between the branches versus loops or branches versus links directly. So branches versus loops means, say the branch would be a J and loop is nothing but the ith loop. If any branch, suppose if you are taking the orientation of this is like this. So this would be a basic loop and the direction of this is towards this, let me assume. And the direction here it is B element and this is downwards, let me assume. So this is E. So this is node number 1 and this is node number 2 and this is node number 4. So this is the basic loop. And what is the direction of this basic loop? The direction of the basic loop is in the same direction of the link. So the direction it would be like this. So it is in the clockwise direction. So if in this particular loop, if any element is traveling in the opposite direction to the loop direction, that will be negative, or if it is in the same direction, that will be positive. So that is the reason we have to start analyzing with the help of simple example. Now if you could see here, now more exactly E. Through this element number E, whatever the loop, in which direction it is traveling like this. What is the direction of this E? This is also traveling in the same direction. So what about the incidence, equivalent incidence of this? So it will be +1. Similarly, now D is also traveling in the same direction. So it will be positive. Suppose if you are going to change the direction of this D like this. So especially in the D, the loop is traveling in this direction and the element is downwards. So this loop, with respect to this loop, this branch is moving in the different direction, means opposite direction. In that cases, it will be negative. So that is the meaning of +1, -1 and 0. So if there is no relation at all, suppose with respect to this basic loop, if you are talking about one more branch which is associated with another loop, then there is no question of any relation existing. So in that cases, it is going to say it is 0. So what about the construction step? How we are going to develop this Tricep matrix means, first of all, you have to identify the graph. Now graph we are going to deduce from the basic electrical circuit, but circuit we are going to analyze. So from that circuit, you have to develop the graph. Then again from that graph, with some basic steps available to develop the tree, with the help of that steps, you have to develop the tree, and then you have to identify the basic loops, basic independent loops. So direction of the basic loops is also very important. So the direction of the basic loops is corresponding to the link. Corresponding link is, the terminology is very, very important, because in any graph we may see few links, but which is the corresponding link corresponding to that basic loop is very, very important. So in the corresponding link direction only, the basic loop is oriented. So that is why the corresponding link with respect to that basic loop is very, very important. Then after that one, replace or prepare this Tricep matrix with the element of Bij. So already we have discussed when it will be positive, when it will be minus, and when it will be 0 also. So let me examine. So this is one basic problem. So in this one, let me exercise how we are going to fill the elements in the matrix B. So that is nothing but the basic Tricep matrix. So this basic Tricep matrix, so it was clearly given that this is the node 1, and this is node number 2, and this is node number 3, and this is node number 4. And what are the sides? I mean to say, how many number of branches, and more exactly if you are saying how many number of elements it is having. So element 1 and element 2, element 3, 4, 5, 6. So there are 6 elements are there. So in another way, so how many number of branches are there? There are 6 branches are there. So the element A, element B, element C, element D, element E, element F. And on this side, what are the basic loops? So that basic loops is nothing but loop 1. This is not the node exactly if we are speaking. So let me write like this. So node number 2, and this is node number 1, and this is node. I mean to say loop 1, loop 2, loop 3. So what is the relation between loop 1 and element number A? That's what this element inside this basic Tricep matrix. So element 1. So this is the loop 1 is clearly marked here. So this is the loop 1, outermost one. Now in that one loop 1, whatever the element A, in what direction it is there. So whatever the direction of this loop 1, so the direction is nothing but in the associated one. So this is like this, right? So what about the relation? Element number A, I mean to say element number A with respect to loop 1. So this is nothing but loop 1. So element number A and loop 1 are in the same direction. So straight away you can mark it as a +1. So next one is loop 1 with respect to element number B. So where is that element number B? Element number B is this. So there is no direct relation, because B is nothing but this B and C are not the part of this basic loops. So that is why we are writing straight away zeros. The next one is element number 1, element number D. So this is the element number D versus loop 1. So loop 1 and element number 2 are associated, but the thing is these two are traveling to each other. So we are going to replace that with -1. Next one is element number E. This is the element number E and loop 1. So there is no direct relation. So straight away you can write it as a 0. And next one is the element number F. This is the element number F and loop 1. So whatever the direction of this loop 1, so this is like this. And here also these two are traveling to each other, traveling in the opposite direction. So you can write as a -1. So this is the procedure we are going to develop the basic Tricep matrices. Similarly, you can examine, let me examine with the third basic loop. This is the third basic loop with respect to various elements. So loop number 3 versus element number A. So element number A is somewhere it was there, but it is not a part of that particular loop, because here the loop is nothing but, this is the loop and the direction is nothing but corresponding link. So corresponding link is nothing but, this is like this, because corresponding link is nothing but the C here. So loop number 3 direction is in the clockwise direction, because that C is nothing but oriented from node number 2 to node number 3. So with respect to this particular loop, that is loop number 3, yes, it is not a part. So straight away we are writing 0. What about the B? B is also a not part. So this is straight away we are going to say, put 0. And basic loop versus 3 versus C. So this is C. So in the same direction, definitely it happens, because that loop, basic loop has been formed because of that links only. So that is the reason we can get +1. And next one is loop number 3 versus element number D. So loop number 3 is somewhere and element number D is somewhere. So it is 0. And next one is loop 3 versus element number E. So it is a part but traveling in the opposite direction. So -1. And loop number 3 versus element number F in the same direction. So it is +1. So here now it is very clear that what are the links here? Link is A, B, C are the links. And twigs are, these are the links. And twigs are D, E, F are the twigs. Now here, if you could clearly observe in the basic Tricep matrix, these first three are the elements. Of course, more clearly, these are the links. These are also elements. More clearly, these are the branches. I mean to say twigs, not branches. More clearly, these are the twigs. So this bus Tricep incidence matrix can be divided into two submatrices. So this is nothing but it is a identity matrix. Why identity matrix here? Why? Because this subgroup, this graph or sub matrix is nothing but because of the relation. If you could see here, this is links versus basic loops. These are the basic loops here. These are the basic loops, and these are nothing but the links here. So basic loops versus links. Basic loops versus links. Always these basic loops have been formed because of the links only. So this relation straight away gives us identity matrix. So another submatrix might be different, but now we can understand like this. So links versus basic loops always gives a identity matrix. So one more problem we can examine here. So one portion of the graph can be represented here, and the solid continuous lines are nothing but the twigs. So twig is here. Twigs are element number 1, element number 2, and element number 3. So links are element number 4 and 5 and 6. So these are the links. So how many basic loops we can see? So number of links are equal to the basic loops. These are the basic loops. So these basic loops can be earmarked with 1, 2, 3. So these are nothing but the Tricep or basic loops. So on above the table, so how many number of branches means elements? So there are 3 twigs are there, 3 links are there. So 1, 2, 3, 4, 5, 6. Then loop number 1 or Tricep 1 versus element number 1. So Tricep 1 is this. This is the Tricep 1. Element number is this. So in the same direction, so we got +1. So element number 2 is this. This is the element number 2 versus first Tricep are in the opposite direction. So we got -1. Loop number Tricep 1 and element number 3. So element number 3 is here. So there is no incident at all. So like this, we can proceed and we can fill this particular Tricep matrix with associated elements either +1 or -1 or 0. So one more incidence matrix is basic cut set matrix. So in this one, it is very simple. The size of this matrix is nothing but we are going to use a letter C to represent the basic cut set matrix. So in this one, a cut set is a minimum set of branches of a connected graph such that when it is removed. So don't confuse all these things. So already we know this graph here. So this is the graph. So this is the node 1 and this is node 2 and this is node 3 and this is node number 4. So this is one element and this is another element and this is one more element. Now this is the graph and especially tree and co-tree also, right? So in this one, how we are going to examine this cut set matrix means, in this cut set matrix, divide this total graph into two halves, not equal halves, just halves. I am going to divide this entire graph into two halves by eliminating one node by disconnecting associated branch. That is very, very important here. Now, what is this? I am just repeating once again. Please be attentive. So, I am going to cut this total graph into two parts across any nodes. So, that node means now you just remove this node 1 by cutting one of the twig, one of the branch that must be a twig here. So, how many number of twigs are there? So, this is the one twig, this is the another twig, this is the another twig. So, there are 3 number of twigs are there. So, you have to cut this total graph by cutting the twig in order to eliminate one of the node. So, see, I am going to cut this particular twig like this to eliminate or to isolate node number 1. So, this is nothing but like this. If you are cutting this total graph like this, so we can see two subgraphs. One subgraph is associated with node 1 and another subgraph is rest of the graph. So, like this, you can divide any graph, given graph, into two halves, two parts, in order to eliminate or in order to isolate one of the nodes by cutting the associated branch. So, associated branch means especially twig. I mean to say twig. So, this is a twig here. So, twig, I want to eliminate, I want to isolate node number 1. So, this can be done by connecting or by bisecting the twig. So, this is the cut set here. So, this cut set have been formed with respect to what? With respect to this particular twig. This is nothing but the twig 1. So, T1 let me assume. So, this is nothing but the cut set 1. Similarly, one more twig is there. This is nothing but, so element node number 2, you can cut this node number 2 or you can isolate this node number 2 by bisecting or by cutting this twig number 2. Now, this is we are doing in order to isolate node number 2. Similarly, node number 3 can also be isolated by cutting like this. Now, this cutting can be done through one twig, but you should not cross another twigs in this procedure. This is very, very important. Now, cutting can also be done like this. So, if you want to eliminate node number 4, now if you are expecting a cutting like this, this is not a cut set. You can divide this graph in any different ways, but basic cut set means you have to divide the graph into two parts in order to isolate one of the bus node or node by cutting one of the twig. Now, this I want to eliminate, I want to remove, I want to isolate this node number 1 by cutting this twig. So, this cutting of the twig is nothing but we are cutting this twig in order to isolate node number 1. So, this cutting of this twig is nothing but it is a basic cut set. Similarly, node number 2 is there, node number 2. So, you can also remove this node number 2 by cutting one of the twig. So, that twig is nothing but this is the twig here. So, this can be achieved like this. So, what is this? This is also one of the basic cut set. Similarly, you can also remove this node number 3 by cutting this twig. So, that is nothing but the cutting can be done. So, this is nothing but one more basic cut set. So, here one important point, you can divide that matrix or you can divide the total graph into any equal number of parts or any parts, but the cutting should be through twig. So, if the cutting, if you are going to divide the total graph into two parts by cutting any twig, so that could be a basic cut set. So, another way is nothing but you can do in any another manner, but that won't be a basic cut set. So basic cut set means you have to divide the graph in order to isolate one of the nodes, and you have to divide that graph into two parts through twig. That is very, very important here. So twigs are the branches of the tree and links are the branches of the core tree. The number of cut sets is equal to how many number of twigs are there. This is very clear. So twigs are nothing but n-1 are the twigs, and this cutting could be done in order to eliminate one of the node from the existing graph. So whatever the direction of this cut set is very, very important. The basic cut set direction is in the associated twig. In which direction the twig is oriented, in the same direction the basic cut set will be oriented. So what are the steps to draw the basic cut set matrix means? There are some basic steps are available. Draw the graph of a given network or electrical circuit, whatever it may be. Then draw its tree, and the branches of the tree will be twigs. So how many number of twigs will be there? So n-1 number of twigs will be there, because this number is very, very important. So based on this number only, we can identify the basic cut sets. So number of twigs will be equal to the basic cut sets. So then draw the remaining branches of the graph by dotted lines. These branches will be links. Yes. Now we know how to draw the twigs and we know how to draw the links also. And the number of twig of a trace will form a independent basic cut sets. And we know what is the procedure also. Let me take one example. And whatever the direction of whatever the elements, when it will be +1, when it will be -1, when it will be 0. That is also very, very important. So the direction is nothing but any element if you are taking, that element is nothing but the C. The element is nothing but the Cij. If ith cut set. So first letter is nothing but it is a basic cut set. And J is nothing but, this is nothing but element. So if ith cut set is oriented in the same direction of the jth element, then it will be +1. If ith cut set is in the opposite direction to the jth element, it will be -1. If there is no incident at all, then it will be 0. Anyhow, we know and we are habituated to identify the various elements in the basic cut set matrix. So let me examine with one simple problem. So write the cut set matrix of the below network. So this order of the cut set already we know that the number of twigs will be the basic cut set and the number of branches. So how many number of branches are there? As usually A, B, C, D, E, F. And how many number of cut sets? How many number of basic cut sets means number of twigs. So first cut set. So the way of representing here it is C1, C2 and this is C3. So first cut set is this. This is the first cut set, the basic cut set versus element number A. So element number A is like this. So element number A is like this, and cut set orientation is also in the same direction, because now who will assign what is the direction of this basic cut set means that basic cut set have been developed because of element number D. And second basic cut set, this is the second basic cut set was developed because of E. And third basic cut set is because of one more twig, so that is EF. So the direction of this F is the direction of third basic cut set. The direction of E is the direction of this basic cut set second, and the direction of D is the direction of first basic cut set. So first basic cut set versus element number A. So this is element number A versus first basic cut set. So what is the direction here? C1 versus A. So in the same direction these are oriented. So it will be +1. So C1 first cut set versus element number B. So these two are traveling in the opposite direction. It will be -1. And C1 versus C element, there is no incidence. This is 0. And first cut set versus element number D, definitely it will be in the same direction. So +1. And E, there is no incidence at all. F, there is no incidence at all. So this is the procedure to develop the elements of this basic cut set matrix. Now here also, if you could keenly observe, this ABC, these are nothing but ABC are associated with links, and this relation is associated with the twigs. In the basic cut set matrix, so these rows are nothing but C1, C2, C3s, these are nothing but the basic cut sets. These are the basic cut sets, and D, E, F are the tweaks. So if you could observe here, basic cut sets have been formed because of the tweaks only. Just because of tweaks only, basic cut sets came into picture. So this is a subgraph. This is a submatrix. You can divide this basic cut set matrix into two parts. So this one portion, this particular portion, this portion is nothing but it is. If you could observe here, this is nothing but it is an identity matrix. Why it is identity matrix here? Identity matrix because C1, C2, C3s have been formed because of the tweaks only. So what could be the relation and the orientation of these basic cut sets are also with the help of tweaks only we have earmarked. So in the direction of the tweaks only, the basic cut sets will be oriented. So definitely the relation, definitely it will be a unity identity matrix. So this is about the different incidence matrices. I hope you understood very well. In the next coming videos, we are going to discuss about the method, the procedure to calculate the currents and voltages of the parent electrical circuit. Thank you for watching with this video. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.